All right, this is part 2 of the 6.2 notes from what would have been Thursday's class. So looking at this problem right here, number 4, find the height of a building if your view is 60 degrees to the top and the roof is 38 meters in your field of vision. So let's draw a picture of what this is going to look like. So we've got a building we're trying to find the height of. We're somewhere over here looking at it. And we've got this angle of elevation that we're looking up into the building is 60 degrees. And our field of vision means our line of sight. So we have 38 meters. So the first thing you want to do is figure out what is the relationship between your angle and these two sides that we are looking at. So that's opposite over hypotenuse. So that's going to be sine of 60 degrees is opposite over hypotenuse. And we already know sine of 60 from our chart. This is in the first video. If you look up here, and you will want to have all of these memorized. It's going to be important. It is square root of 3 over 2. We're going to be talking more about that when we do the unit circle in class. So since this is a special triangle, we can replace sine of 60 with square root of 3 over 2. And we're going to cross multiply. So that's 38 square root of 3. And then equal to 2h, and I'm going to divide both sides by 2. Sorry, I went ahead and drew my division in there. That's going to be 19 square root of 3, and this is meters. Now, if they wanted, this would be the exact answer. If they wanted an approximation, because you're probably not going to go up to someone and say, my building is 19 and square root of 3 on the square root of 3 meters tall. So we could put into our calculator square root of 3 times 19. That's about 32.91 meters. So this would be the approximate. So it just depends on what they ask for. So you have to read your directions really carefully, especially on the test and on WebAssign, to see if they want exact or if they want approximate. I always say if they don't give you rounding instructions at all, they want the exact. Okay. A bullet is fired at a 45-degree angle up to into a tree limb. If the tree base is 18 feet from you, how far did the bullet travel? Okay, so we've got, again, me, and I'm looking up 45 degrees to a tree limb. And my drawings aren't perfect, especially with this pen. That should be the bottom of the tree. On the ground. This is 45 degrees. This is our right angle. And if the tree base is 18 feet from us, so how far did the bullet travel? Well, we're looking at this. The bullet was going up into the tree limb, so we're looking for this hypotenuse here. Okay, so this is adjacent in height, so that's going to be cosine of 45 degrees equals the adjacent over the hypotenuse, and cosine and sine are both square root of 2 over 2 when the angle is 45 degrees. That was from our special triangle discussion in the first part of the video. This is 18 over x still. Cross multiply, square root of 2x equals, is that 39? And then, no, that's not 39, 36. Sorry, mental math. Double check myself. Yeah, 36. And then we're going to divide by square root of 2. Now this is going to need rationalizing if we're going to leave it exact. So times square root of 2 over square root of 2. That's 36 square root of 2 over 2. That's going to reduce down to 18 square root of 2. And this is in feet. So there's my exact. If I want my approximate, I'm going to need to multiply square root of 2 times 18. Which on my calculator I just did, and that's 25.46 feet. Okay, so those are the application problems with angles of elevation. If we consider the idea that a triangle is created from an angle that has been rotated, we can use an initial side as the positive x-axis. So we're going to be putting this on the x and y grid, our rectangular coordinate system, and the terminal side as the moving counterclockwise on a standard coordinate plane. So across the quadrants in the order 1, 2, 3, 4. That's what we mean by counterclockwise, so this direction. Although it could be negative instead of positive if we're moving, remember, clockwise. This would mean that the point P, which is the point we've labeled here, with standard coordinates of x and y, so a certain distance right or left and up or down, tell you the height opposite side of y. So this is going to be, y is going to be our height, and our adjacent is going to be our x. And then by knowing these, we can rewrite our 6 trig functions based on x, y, and r, which we're going to call this the radius to the point. We can imagine if we kept going around at that same distance, we would have a circle, essentially. That's why this is going to tie into the unit circle. You can then use them to solve for the functions from a point P on a terminal side. So we're using this as our theta. So again, sine of theta is y over r, opposite over height. Cosine of theta is adjacent over height. Tangent of theta is opposite over adjacent, so opposite over adjacent, and then the reciprocals. So let's talk about how we could use this then to solve for missing sides. And I do want to note out, let's talk about our signs. In this scenario right here, we have that everything in quadrant 1 is positive because these are x's that are positive and y's that are positive. In quadrant 2, which is the top left quadrant, you have negative x's but positive y's. So those ordered pairs are negative positive. In quadrant 3 down here, you're going to have all negatives because you're down and to the left for your coordinates. And in quadrant 4, you're going to have positive x's but negative y's. So that's important to know. And there's also another little saying that I'm going to draw in just a second about our trig functions and how they relate to these different quadrant positions. But let's first do an example of just drawing one in its correct quadrant and finding the values of those trig functions of theta. So we have to plot this point first. So if you think about drawing an x and y axis, negative 15 and positive 8 is going to be in quadrant 2. So you don't have to, you just think about going negative 15 and then up 8. We're not going to mark all the little grid lines. We're just drawing a rough sketch. That's going to be our point P. Draw a triangle that drops straight down. That's where your right angle is going to be. And the angle of concern that we're looking at is always this right here, this theta. Okay. So this is negative 15 for the x and positive 8 for the y. And then we need to find our r, our hypotenuse. R should always be positive. That's just because that's by definition, it's going to be our radius of our circle if we were thinking about drawing a circle around here. So 8 squared plus negative 15 squared equals r squared. So that's going to be 64 plus 225 equals r squared. That's 289 equals r squared, and that would be r equals 17 when we take the square root. It is technically plus or minus 17, but we just said that r is always going to be positive. So 17. Okay, so now we have everything we need to make our ratios. So opposite over height would be 8 over 17 from our angle. Cosine would be adjacent over hypotenuse. Tangent would be opposite over adjacent, and you can pull that negative sign out to the front when it's in the denominator. Cosecant's the flip of sine, so that's going to be 17 over 8. Secant is the reciprocal of cosine, so it's going to be negative 17 over 15. And cotangent is going to be negative 15 over 8. Okay, let's try another one. So it says using the point 4, 5 on the terminal side, find the values of the 6 trig functions of theta. Okay, so let's draw this one. This is positive, positive, so we're going to be in quad 1. So we have, and this time, since it's small numbers, I'll mark them if that'll help. We're going 4 on the x-axis and 5 up on the y-axis. And that's our point P. We draw our angle to that, so the line from the origin to that. We drop down a perpendicular to the x-axis. So we know that this is 4. and this is 5, because those are our X and Y coordinates. And we can find this R again. So this is 4 squared plus 5 squared equals R squared. So that's 16 plus 25 equals R squared. Add that together, that's 41 equals R squared, or the square root of 41. Now that one does not have any perfect squares that go into it. Sometimes you will have to reduce your square root, but 41 is a prime number. No numbers go into it, and we can't break it down any. So sine is going to be 5 over the square root of 41, which we'll rationalize and get 5 squared of 41 over 41. 5 and 41 do not reduce. Cosine is adjacent over hype, so that's going to be 4 over square root of 41, which is going to be 4 square root of 41 over 41 once you've rationalized. Tangent is opposite over adjacent, so 5/4. When I do my reciprocal for cosine and sine, I like to use the version before I rationalize because that makes it less work for me. So sine is member, reciprocal is cosecant. So that's going to be square root of 41 over 5 if I flip this part right here. Secant will be square root of 41 over 4. And cotangent will be 4 out of 5. Okay, so for this next one, this is a little different. So 11, and it's supposed to be 12. Sorry, there is a typo here. I think my numbering got off on this worksheet. Use the identities to find the values of the trig functions. They're giving us 2 pieces of information. They're saying sine is 1/2 for this theta, and the cosine theta is positive. So we need to have a little discussion about where are sines, cosines, and tangents positive or negative. So let's look at this. And actually, I'm going to go back up to my graph. Okay, so notice that in quadrant 1, and you can look at our example we just did, we have everything being positive, right? Nothing came out negative in quadrant 1 because your X and Y are both positive. So in this statement right here, I'm going to write that all are positive. And when we mean by all, we're meaning all of our trig functions, okay? In quadrant 2, which was this example, we noticed that cosine and tangent and secant and cotangent are all negative. And that has to do with the fact that they were built off of this adjacent side. So when you're in quadrant 2, the only thing that's positive is sine and its reciprocal cosecant. So sine theta and cosecant theta are positive, okay? Let me write that a little neater. And that's because they're a family, they're reciprocals of each other. And then down here in quadrant 3, we have X and Y's are both going to be negative. So what's going to happen is when you put them over a positive hypotenuse, you're going to get negative answers. But when you make a ratio of 2 negatives, which is tangent, you're going to get negative over negative, which is positive. So what's going to happen in quadrant 3 is that tangent theta and cotangent theta are going to be positive. Okay. And then in the final one down here, this is going to be positive X's but negative Y's. So that's going to make sine and tangent both negative, but our cosine and our secant are going to be positive. So that's a lot of information. So there's a way to remember this, and it's all students for sine take T for tangent calculus. Now that's not a true statement, but it helps you memorize which of the family main trig functions is positive in that specific quadrant. So all means all of them, all 6. Students means the sine family, which is sine and cosecant. Take, which is tangent and cotangent. Calculus, which is cosine and secant. Okay, so now that we're equipped with that information, let's go down here and reread this. So sine is 1/2. That's actually given to us as a positive ratio. Well, sine was positive in quadrants 1 and quadrants 2. Remember, all students. So sine is positive in quadrants 1 or quadrant 2. Cosine being positive is going to happen in, first of all, quadrant 1, and then it was also positive in quadrant 4. Now, once you've seen what the two situations are, they're going to have one in common. That's how you know where to draw your triangle. So because sine is positive in quadrant one and so is cosine, because this is a positive ratio they gave me, I can draw a quadrant one triangle. So let's draw that out. So we needed to determine that first though. So remember, our theta always comes up from the origin. We have our perpendicular down to the x-axis, and this is opposite over hypotenuse. So 1/2. We're going to use Pythagorean Theorem, solve for the x value this time. So that's 1 plus x squared equals 4. X squared equals 3. So x is the square root of 3. Okay, so we have 1/2 that was already given to us, which means we also know that cosecant is 2/1 or just 2. We have adjacent over hyp is square root of 3/2. So secant is 2 over the square root of 3, which we will rationalize to 2 square root of 3/3. Tangent is 1 over the square root of 3, which we will rationalize and get square root of 3/3. And cotangent would be then just square root of 3/1, which is just square root of 3. Okay, so let's try another one similar to this. It says use the identities to find the values of the 6 trig functions. Okay, so tangent is negative this time. So tangent is negative in quads 2 because sine is positive in quad 2, or in quad 4 because only cosine's family is positive in quad 4. So that means sine and tangent are negative in both of, well, in one of those it's sine and tangent, and the other one it's cosine and tangent that are negative. So whatever quadrant you're in that the family is positive in, the other groups are going to be negative. So that's why this is 2 or 4. Tangent is only positive in quad 1 and 3. Sine is positive in quad 1 or in quad 2. Okay, so because our match this time is quad 2, that's where I'm going to draw my picture. And I need to know that because that really does determine where this negative is going. Is it going with the 3 or is it going with the 4? If this was like a sine or cosine, it's very easy to determine that because you know the hypotenuse should always be positive. But because it's opposite over adjacent, we don't know just by staring at it which one is the negative. So that's why knowing the quadrant is important because that does affect the signs of my other trig functions. So I'm in quad 2. Remember, we have opposite over adjacent. So notice I didn't put the negative down yet, but because we're in quad 2, that means we have negative x's and positive y's. So that's going to be a negative x and a positive y because y is up and down. And then we're going to use Pythagorean theorem to get that hypotenuse. So that's going to be 9 plus 16. That's 25. So this is a nice Pythagorean triplet triangle, the ones that come out all nice numbers. So, and then remember, hypotenuse is always positive. So we already knew tangent was negative 3/4, which means we know that cotangent was negative 4/3. You didn't even need to draw the triangle to get those two. And then for this, opposite over hypotenuse is 3/5. And that makes cosecant 5/3. Adjacent over hyp is negative 4/5. And that makes this negative 5/4. So it was really important that we knew to draw this in quad 2 because we would have gotten the signs wrong if we just guessed, possibly. All right, so this next thing is just a lead-in into something we're going to be covering more heavily later. But along with functions, we can also use definitions of each function to prove identities. This is going to be useful later to transfer complicated looking statements into much more manageable ones so that we can work through the problems. So just for example, this is an identity. Cotangent of theta times secant of theta is equal to cosecant of theta. If you just use, now there's different philosophies of thought. Some people say you can work on both sides at the same time. Some professors will have you prove you start at the left and you go to the right only, so you don't touch the right side. We'll talk about that more when we actually get to those sections and what I prefer, but I just wanted to show you this is the generic work everything at the same time. We just turned all of these into their ratios of using definitions. These are the reciprocals, and this is the opposite of tangent, which is sine over cosine. And what you notice is that the cosine theta is then reduced and you get 1 over sine equals 1 over sine theta on both sides. So this is just a little taste of kind of some stuff we're going to be doing later on. Another way to write degrees. So we did degrees into radians, but we want to know, is there another way to talk about degrees, is to avoid using decimal points and use what we call minutes and seconds. This is something used in navigations. You use it as fractional portions of loops around a clock. And we know that a clock has 60 minutes for one full loop and 60 seconds for a full minute loop. So we're going to turn this number 32.6385 degrees into degrees, minutes, and seconds. So the first thing you do is you are going to write down the whole number. That is your degree. Okay, so that's the 32 degrees is going to stay degrees. Then we're going to find the number of minutes by multiplying the 6385 by 60. So notice that is 38.31. You take the whole number of that part and that becomes your minutes. And then you take just the 0.31 and you times that by 60 again to turn it into seconds. So that's going to be 18.6. Round that up to, or down, depending on the decimal, to the seconds that you're supposed to have. So this would be 32 degrees, 38 minutes, which is a single little mark, and 19 seconds. So let's do one, except this one's a little trickier for us because it's not starting in degrees. So we have to convert this to from radians to degrees first. And then we'll turn it into the ratios of degrees, minutes, and seconds. Okay, so 10 radians turned into degrees. Remember, it's already in radians, so the radian pi unit will be on the bottom times the 180 degrees on the top. So this is going to be 1800 divided by pi. So divided by the pi. That's 572.9. I'm going to write it out to 6 decimal places. Well, we'll do 4. We did 4 in the other example. So 9578. Sometimes I like to go a little further. Now, there's 2 problems with this. First of all, this is more than 1 revolution around a circle. So we want to reduce that down to a coterminal angle. So take your 572.9578 and we're going to subtract 360 from it just to get a coterminal angle that's between 1 revolution around the circle. So this is equivalent to 212 degrees, 0.9578 still. So 212.9578 degrees. Okay, now we're going to do our conversion to degrees, minutes, and seconds. So this is going to be 212 still for the degrees. And we're going to take this part right here, and we're going to take 0.9578 times it by 60. And you only want to use the decimal part. You don't want the whole number part. And that's going to be 57.468. So that means we have 57 minutes. And you're going to take just the 0.468 times that by 60 again. And that's going to be 28.08. And we round to the nearest whole there. So that's going to be 28 minutes. So there is that radian value in degrees, minutes, and seconds. Now, we didn't have one in the notes. I'm going to add something in real quick on how to go the other direction. And I think we should talk about that. It's just not as, I don't think it's as complicated, but that's my personal opinion. So I want to make sure we go through it. So let's say we had, we know what this one turns back into for radians and for degrees. So let's say we had 212 degrees, 57 minutes, and 28 seconds. Let's say we wanted to convert back to just regular degrees only. So this is just extra for this one. You didn't have to do it. So the big thing is, you know that this is going to be your whole number in front of your decimal. And the way you convert these back is you take 57 and you divide it by 60. And then you take 28 and you divide it by 60 twice. So in other words, 3,600, because you divided by minutes and by seconds for this one. So it's going to end up being, so let me write this out a little differently. 212 plus whatever this is, we're going to get a decimal for that, plus this. So you just have to individually convert them back into their decimal portions. So 57 divided by 60 is 0.95. And 28 divided by 3,600 is 0.0078, if you round it to 4 decimal places, and that equals 212.9578, which was our original degrees once we had converted from radians to degrees. So just FYI, you can go either direction, little different process though, and that is the end of this video.